Okay, so now we're going to look at the behaviour of a Zener diode when a DC power supply is varied on its input and see what happens at the output. This should give a good characterisation of that Zener diode. So on the breadboard we've got DC power supply coming in on the red wire. We're going to start that at 0 volts and increase it step by step towards 20 volts. And we've got its return line on the black. The positive inputs going through a 1 kilo ohm resistor to the cathode of the Zener diode. Note the band marks the cathode. And then the other end at the anode of that Zener diode is connected straight back to the DC supply, and we've got a voltmeter across that Zener diode from the orange wire to the blue wire, so straight in parallel across the Zener diode. So what we're going to do now is apply the voltage output. So while not much might be seen on the circuit at this point, if we skip over to the power supply and the multimeter, we should be able to see something happening. So 0 volts going in, we've pretty much got 0 volts coming out. Okay. If I raise the input voltage to 1 volt nominally on the power supply, on the multimeter I'm going to see 1 volt coming out. If I go to 2 volts on the power supply, 2 volts coming out. It looks pretty proportional here. Three volts in, 3 volts out. Four volts in, pretty much 4 volts out. 5 volts in, 5 volts out. Looking pretty corresponding, pretty linear. 6 volts in, 6 volts out. The Zener diode we've got is a 6.2 volt Zener diode. So let's see what happens. 6.2 in, 6.2 out. Start to raise above 6.2 volts on the input to 7 volts, still 6.2 volts coming out. Go to 8 volts, 6.2 is coming out. 9, 10, and so forth. So it looks like at this time a Zener diode is restricted right up to its rating of 6.2 volts out, irrespective of what voltage has gone in between 6.2 and 20 volts.